Welcome to The Explainer. Today, we're going to crack open a problem-solving technique that's so powerful, it's like having a universal translator. And it's not just for science. This thing lets you tackle complex problems in just about any field you can imagine. All right, let's get into it. So take a look at this. It's a real-world problem an engineer might face. At first glance, it just looks like a jumbled mess, right? You've got liters, kilometers, miles, gallons. It almost feels designed to be confusing. But here's the secret. The roadmap to the answer is actually hidden right there in the problem itself. We just have to learn how to read it.
And that's exactly what we're going to do. We'll start by uncovering a problem-solving superpower. Then I'll show you how to use it to spot mistakes instantly. After that, we'll build that step-by-step roadmap, and you'll see how this one tool works everywhere, from physics to finance, turning you into a kind of universal translator for problems.
So what is this big superpower? Well, it's not about memorizing a ton of different formulas. It's about really getting one single idea that's going to change how you look at every equation from this day forward.
It's called dimensional analysis. And I know the name sounds kind of stuffy, but the idea couldn't be simpler. You basically treat units, like meters, seconds, or even dollars, not as little labels you tack on at the end, but as real algebraic variables. You know, things you can actually multiply, divide, and, most importantly, cancel out.
And that's the key right there. The units themselves guide you to the answer. They're not just sitting on the sidelines. They are active players in the calculation. Once you really get that, problem solving becomes this cool puzzle where the pieces, the units, literally tell you how they fit together.
Okay, so let's start with maybe the most practical use of this superpower, turning you into a human error detector. You can literally tell if a formula even has a shot at being right.
Imagine you're a teacher, and a student gives you this formula for force. Now, maybe you don't remember the exact physics equation off the top of your head. Doesn't matter. You don't need to. You can use dimensional analysis to check their work. How? Well, you just look at the units.
And look at how obvious the mistake becomes. On the left, with the wrong formula, we plug in the units for mass, that's kilograms, and for acceleration, meters per second squared. But then we square the acceleration like the formula says, and we get this totally bizarre unit, kilogram meter squared per second to the fourth. I mean, what even is that? It's not force, I'll tell you that. But now look at the right. With the correct formula, the units combine to give us kilogram meters per second squared. And guess what? That is the definition of a Newton, the unit for force. The units on both sides match perfectly. They showed us the way.
This whole thing works because of a basic rule called dimensional consistency. All it means is that the units on one side of the equal sign have to be the same as the units on the other. If they don't match, the equation is just plain wrong. End of story. It's a super powerful first check for pretty much any calculation.
Okay, checking for errors is great, but how do we actually use this to solve a problem from scratch? This is where we learn to build that roadmap, the thing that will guide us all the way from the question straight to the answer. To make this feel a little more real, let's use a few analogies. You can think of your starting unit as where you are right now, and your target unit as your destination. Conversion factors? Those are just the roads that get you there. Or think about it like money. You can't spend dollars in Europe, right? You got to exchange them for euros. Units are the exact same way. And my personal favorite is the dominoes. Each step has to perfectly knock over the next. If just one is out of line, the whole thing stops.
And the tool we're going to use to line up those dominoes is often called the fence or train tracks method. It's just a really simple visual way to keep all your conversions organized and make sure everything cancels out just the way it's supposed to.
And the process itself is just beautiful in its simplicity. Step 1, you write down what you know, the given value. Step 2, find a conversion factor, something like 1 mile equals 1.609 kilometers. Step 3, and this is the most important part, you set it up as a fraction so that the unit you want to get rid of cancels out. And then you just do it again and again until you land on the unit you were aiming for.
So here's what that looks like in practice. We're starting with 65 miles per hour. First, we need to get rid of hours, so we set up a fraction with hours on top. See that? The hours on the bottom cancels with the hours on top. Gone. Next, we want to get rid of miles. So we set up our next fraction with miles on the bottom. And just like that, the miles cancel. The only unit left standing is kilometers, which is exactly what we wanted. All that's left is to multiply and divide the numbers.
Now, you might be thinking, okay, that's a neat little trick for my math homework. But this same exact roadmap is used by professionals every single day to solve some seriously complex problems across all sorts of fields.
So let's see how this goes from just a simple conversion to a real multidisciplinary tool. The logic doesn't change one bit, whether you're converting miles to kilometers or you're calculating something like energy yields.
For instance, in physics, you can use this to prove the law of conservation of energy. You can actually track the units for mass, gravity, and height in the potential energy formula and see that they combine to make joules. Then you can do the same thing for the kinetic energy formula and, what do you know, it also comes out to joules. The units prove that the physics works.
And in chemistry, this method is the absolute backbone of a huge topic called stoichiometry. If you want to figure out how much aluminum oxide you can make from a chunk of aluminum, you build a roadmap. You convert grams to moles, then moles of one thing to moles of another, then back to grams. And the units are what guide you every single step of the way.
And it's not just for science. Think about economics. If a company makes its money in US dollars but has to pay its bills in euros, they have to use this exact same process. The currency exchange rate is just another conversion factor. Getting the units right here is literally the difference between making a profit and having a terrible quarter.
And after you run the numbers, you convert your revenue from dollars to euros, subtract your expenses, and then convert that profit back into dollars, you get a real answer. This isn't just some abstract classroom exercise. This is how global business works. That number you see is the result of a perfectly built unit roadmap.
So, we've seen this tool in action all the way from the classroom to the boardroom. What are the big takeaways? How do we wrap this powerful idea up? Here's what I really want you to walk away with. First, units are not just labels. They are your guide. Always listen to them. Second, dimensional analysis is your built-in error checker. Use it. Third, that fence method gives you a clear visual roadmap. And finally, remember, this is a universal tool. Once you get this way of thinking down, you can apply it almost anywhere.
So at the end of the day, it really all comes back to this one idea. Don't get lost in the numbers, and don't let a complex-looking problem intimidate you. Just start by building your roadmap. If the units line up and cancel out the way they should, you can be confident you're on the right path.
This whole skill is about empowering you to translate a confusing problem into a series of clear, manageable steps. It gives you a place to start, a way to check your work, and a clear path to the solution. So, my question to you is, now that you have this tool, what problem are you going to solve?